so our next shape, instead of it being 2, this is going to be called AX3. So this is my AX3 shape, okay? So now I've got 3 of these guys. So let's start with our linear, our basic shape, and then this third guy is going to come in. So where is he going to come in? So he's going to come in and say he tries to he doesn't want to be over here because he doesn't want to be next to this guy, you know? So he kind of wants to be in between. So if he goes in between, this is what happens. He would go here. But then you notice that these two are kind of close together compared to the distance we have here. So what happens is this guy kind of goes down a little bit and this guy kind of goes down a little bit to make this shape, okay? If you notice, what is this shape? It's a triangle. So each one of the points of the triangle is where one of my atoms are, and the center is in the middle of my triangle. So you have your 3 points in the middle. So this is called trigonal because it makes a triangle. So we got 3 electron groups. This is called trigonal. But if you notice, it's in the same plane. So when we talk about planes, we're talking about same level. It's not above or below the central atom. They're all on the same level. So this is trigonal planar. All right, so let's think about what this would be. This, if you took the whole thing, it's a circle, and I have 3 parts of my circle. Think about it as like 3 little halves, little pieces of pie in my circle. So if it took my circle and divided it into 3, so a circle is 360, and divide that in 3, then each one of these little halves is 120. So this is what it would look like if you have 3 electron groups. So here would be your Lewis structure. You would say 1, 2, 3. So I have 3 electron groups. So this is my shape. Even though this is how we draw it, Lewis structure, this is the 3D shape. Trigonal planar, 120 degrees. All right, so here's my balloon model. So if I tied the balloons together, they would all want to try to spread out. Remember, it doesn't matter if it's a single bond or a double bond, it's electron groups. So there's 3 electron groups, so they're all 120 degrees away from each other. Now, what does matter is not the bonds themselves, but what's attached. So here, we have an oxygen and 2 hydrogens. Oxygen is more electronegative, okay? So what's gonna happen is that it doesn't wanna be as close to these hydrogens. So it's gonna push the hydrogens a little bit away, and the oxygens are okay with being close together. So this ends up being bigger than 120. So this is gonna be bigger than 120, and this is end up being less than 120. So when we talk about the perfect, we're talking about our perfect shape is when all 3 of the atoms are the same. When they're not all 3 the same, it's gonna deviate from our perfect angle. You don't have to know the exact numbers. So you don't have to know this. You wouldn't be able to just look at it and know anyway. What you have to know is that the perfect is 120, and if they're not the same, then they're gonna deviate. Whoever is the most electronegative, his angles are gonna be greater than 120. The other one would be less than 120, okay? More models, ball and stick model, space filling model, and so that is my trigonal planar geometry, okay? So that's 3 electron groups. On the next video, we're gonna do 4 electron groups.